Alright, so let's take a look at part of section 2.6, which is called Piecewise Functions. We can look at here is an example on the right of something that's called a piecewise function. Notice that there are three distinct parts, this little red section, this blue section, and this green section. This is kind of a strange looking graph. Based on the vertical line test, this actually would pass the test and is in fact a function, but it's unlike one that we've seen before. We have a horizontal section, which appears to be linear. We have something that almost looks like part of a parabola, and then we have a negatively sloped line. In terms of figuring out what the equation would be for this function, it would be pretty tricky to figure out. So we're going to take a look at starting with the what the function looks like as an equation or a set of equations, and then how to graph it, and then to work backwards from there. And hopefully we can make some sense of this. All right, let's go. So you can see here that this is actually what the setup for a piecewise function would be. We have f of x equals, and we have multiple parts in here. F of x equals 5 if x is less than -1, and f of x equals -1/2 x plus 4 if -1 is less than or equal to x, which is less than or equal to 5. So what we're going to think about in terms of graphing this is we're going to actually graph it as if this was the entire function, and if this was the entire function, then we're going to break off the pieces that we don't want. So I'm going to start by thinking about how do I graph f of x equals 5. Well, that's really just the equivalent of the line y equals 5. And we know that y equals 5 is a horizontal line. So that's something that we're going to use. The second thing that we're going to graph is the 1/2 x plus 4. And so that's y equals -1/2 x plus 4 is really what I'm going to be looking to graph there. And that's, again, just a line with a negative slope and y-intercept of 4. So I'm going to graph both of these kind of in total. I'm going to graph the top one in red and the bottom one in blue. And so now you can see what I have there. I mentioned that f of x equals 5 is just this horizontal line. And then I did the blue one. I started at a y-intercept of 4 and went down 1, right 2, over and over again. And then starting back here, I went up 1, left 2, again, over and over again. So that's if I graph both lines on the same coordinate grid, but I don't want to have them for both here. So I really only want to think about when I'm using them. And I'm only using this red part when x is less than -1. And so that's right here. That's this this section right here and back. This is the section of the red function that I'm actually really going to want to keep. The rest of it I'm going to want to actually have fall off, and I'll think about that in a second. Meanwhile, for the blue, I only want to use that when x is between -1 and 5. So that's really here from -1 up until right around here. So this is the section, you can see I'm highlighting it here. That's the section that I'm really going to want to keep of the blue line. So I'm going to have the rest of this fall off. So I'm going to start by having the rest of it fall off here first of the red line. Alright, so now I have only the part left that I want there. And now I'm going to have the parts of the blue line that I don't want disappear. And so now I can see that I have the sections remaining that I want. The only thing I really need to do at this point is make sure that I put the correct type of endpoints on each of these. We notice in the first part of this function where I'm saying x is less than -1, to show that I'm not including that -1, I'm actually going to have to put a big open circle right there. That's at that point, -1, 5. That's not actually on the graph there. Meanwhile, for the blue section, x is between -1 and 5 inclusive. So that means for each of those, I'm actually going to put a closed circle at the endpoint. Again, it's closed because of the or equal to. And now I have my piecewise function graphed. So it looks a little strange, but it's just f of x equals 5 when x is less than -1. F of x is -1/2 x plus 4 if -1 is less than or equal to x, which is less than or equal to 5. And so what I can do here is I can now answer a whole bunch of questions based on this. For example, I can figure out the domain of this function, and I can see that it goes forever and ever to the left, comes up to -1 here where there's a open circle, but it jumps down. It actually picks up right away at that -1 again. Then I'm going to follow that along all the way until x is 5, and it stops. So my x values, if I look at my x-axis here, go all the way from -5 and on to the left forever. So my domain is going to be from -infinity up to 5 inclusive. Now range is a little bit trickier because of this little jump that happens here. If you remember what we did before, certainly the lowest value seems to be right here, which is about which seems to be 1 1/2. And then as I make my way up, I'm going to hit everything until I get to this point right here, which is just below 5. It's actually at 4 1/2. And then it jumps, and even though there's an open circle there, I do have several others there as well on the left side. So my range is going to look a little bit different. Going to be, with a bracket, 3/2 up until, no, I guess you could write it either as 4 1/2 or 9/2. And then it's going to be unioned with just the 5. So kind of a strange looking range there, but that's what it is. Is this a function? Any vertical line is actually only ever going to hit this at one point. So I've been calling it a function throughout. It doesn't necessarily mean that it actually was. The only point in question is the open circle above the black, the filled-in circle. But the good news is that because it's open, it doesn't pose any problems. So yeah, this is in fact a function. Now the only other things that are really interesting here is evaluating the function and just knowing which part of the function to use. So for f of -5, which is my first example, -5 is over here. It is on the red section of my graph. -5 is less than -1, so I just have to use that part of the function, and that means that there's nothing really to plug in there. All I'm going to end up with is 5. So f of -5 is 5. F of 2, on the other hand, 2 is over here on the right. That's in the blue section of the graph. 2 is between -1 and 5. So what I have to do is I have to plug into here. And we can see that -1/2 of 2 would be -1, plus 4 is 3. Now -1 is the only one that's really kind of interesting, because that's right where this really gets interesting. But if I take the -1 and I try to see which inequality it fits into, is -1 less than -1? No, that's no good. Is -1 fit in here? -1 greater than or equal to -1 but less than or equal to 5? Yeah, it is. So I just need to plug -1 into here. -1 times -1/2 is a positive 1/2, plus 4 is that 4 1/2, which kind of came up before when you're looking at the range. So you could have that as 9/2. Something that wouldn't be defined here, for example, would be something like f of 6. There's nothing that we can say for that because 6 doesn't fit into either of these intervals. Sometimes that'll be the case, sometimes it won't. But here, there's really nothing that we can do here because of the fact that it's undefined. So we can't evaluate f of 6 here. It doesn't mean that there's a math error, it just means we have no rule for it. All right, that's a little complicated, but I hope it makes sense. All right, so here's another example. This one actually has 3 parts. So I'm going to do this one a little bit faster. See, maybe watch it a couple of times if you need to, but that same general idea. I'm going to do the first part in red, second part in blue, and third part in green. So again, I'm going to start by graphing the entire thing and then getting rid of only what I don't need. I'm going to start with the f of x equals -4 when x is less than or equal to -2. So -4 I know is a horizontal line that looks like this here. At this point I'm just going to start to clean it up kind of right away. I want that when that's less than or equal to -2. So I'm going to delete everything on the other side of -2. And because it's the less than or equal to, that's when I'm going to fill in a closed circle there. Just like a kind of a inequality that we used to do on number lines. All right, next one. X minus 2 for -2 is less than x is less than 2. So I'm going to start by graphing that. Y-intercept is -2, and the slope is 1. So I'm going to just go ahead and graph that. Again, I'm graphing the whole thing. And, oh, hey, I happen to hit that right there. That's interesting. So I've got this whole line right here. You can see slope is 1, y-intercept's -2. And now I only want to look at it for the section between -2 and 2. So I'm going to get rid of the rest of this here. So get rid of this. You can see -2 just happens to hit it, or 2 happens to hit it right there at the x-axis. When I get rid of this here, now it's actually going to come back right into this little dot. What I would normally do is I would have to fill in an open circle, or leave an open circle there, but the red circle actually fills it in. Now that's good, because it doesn't mean that it's going to violate any rules about functions. It actually just kind of connects nicely there. All right, next one, next end of that, I have to do an open circle at the point 2, 0. See if I can get that a little bit better right on to 2, 0. There we go. And that's where we are for now. All right, finally the green one, -2x plus 4. So I'm going to go up to 4. That's my y-intercept. Now a slope of -2 means that I have to go down 2 and right 1. So you can see where I'm going to be going here. I'm just going to mark off all of my points as good as I can. And I could also go up 2 and left 1 if I want to do that. And then I just connect all these guys here. And oh, well, what do you know? I once again go right through that same spot, which is interesting. Now, once again, I'm just going to get rid of the parts that I don't want. So I don't want to include it. I only want to include it when it's greater than or equal to 2. So I'm going to get rid of all of this stuff. And then right at the 2, because I want to include it, I'm actually going to fill it in. And you can see that now this is actually a perfectly connected graph. It's weird looking. It's not, doesn't match any of our basic graphs, but it is connected, which actually means that the domain here is going to be all real numbers because I'm going to go left and right forever. The range, because again it's connected, it does have a maximum of 0, but then it goes down forever. So I'm going to have -infinity up to 0. And once again, this is in fact a function. So pretty interesting. It's just what we have there. All right, so I hope this is pretty clear. Let's try to work backwards now. All right, so here's just an example of where we would try to work backwards. We know we're going to be trying to write a function that has multiple parts. This appears to have 3 parts, so I'm going to set myself up for this where I say f of x equals, and I get these 3 spot for 3 things to go in right here. I'm going to start by identifying what the functions look like, and then from there write the equations, and then figure out what intervals I'm talking about. I usually start on the left here, and I look at this first part of the graph here, which appears to be linear, and so I can see that if I were to extend this line, it might actually help me. I kind of follow it through, and it looks like I would go right through that 2 right there, and then it's it's a little offline, but I think we're going to try to assume that this is kind of having a slope of 1. It's a little tough to see, but that's the general assumption we can make there, because it seems like it's going through that 2 and this one. It looks like it's going to just follow nicely right there. So since this has a slope of 1 and a y-intercept of 2, I'm going to say that this is going to be x plus 2. And so I'm going to put that right there. And I'm just going to clear out the rest of this right here so I don't have to see that. I'm going to worry about the second part after. I look at the second part of this graph here, where I seem to be going from this spot to this spot. Once again, the y-intercept is, in this case, actually pretty obvious. It's 3, but the slope happens to be 1 again. So in this case, I think I'm looking at, whoops, let me try that again. Instead of x plus 2, we're going to say it's x plus 3. And then finally, last one, finally here, we extend this. We see that we have that y-intercept of 1. Again, the slope seems to be a nice positive 1, so I'm going to have x plus 1. I get these 3 different pieces going on here, just looking at the slope and the y-intercept of my 3 lines. So now I just need to figure out what else I have, and when I have these, I should say. So the x plus 2, that's this first part here, which starts at -1 and then goes to the left forever. So for that, I'm just going to say if x is less than or equal to -1. Then for the second one, the x plus 3 happens to run from -1 to +1. They're both open circles, so I'm not going to have any or equal to's here. I'm just going to say -1 is less than x is less than 1. Then finally the last one, closed circle at 1 goes to the right forever, which means that I'm talking about x being greater than or equal to 1. That's pretty much all there is to it. It's takes a little bit of practice, but now that you see what you have to do, I think it's pretty straightforward. All right, hope this makes sense.